Okay, welcome back to graphing functions based upon their multiplicity. So let's look at some things. So we can tell from this graph that it has a 0 at -2 and it has a 0 at 3. At -2, the multiplicity is 2. At -3, the multiplicity is 1, which means 2 plus 1, that means that's a third degree polynomial. And our leading coefficient is positive. So what would this sketch look like? Well, the first thing I would do is sketch my zeros. Okay? Now, because this is third degree and my leading coefficient is positive, I know it looks sort of like this. Okay? That's what my end behavior looks like. So I know it's going to start here. But when I get to -2, it has multiplicity of 2, which causes that to simply bounce. It won't cross, it'll bounce, it'll go back down, and then I have to cross at 3 somewhere else. And so this is what my graph would look like. Notice my end behavior is consistent for what we talked about earlier. Okay, let's look at the next one. We have zeros at -3, 6, and -8. And they each have multiplicities of 1, because that is my exponent on each of those, which makes it a third degree. Notice my leading coefficient is negative. And because my leading coefficient is negative, that means my graph will look like this, sort of upside down. Okay? So I'm going to graph my zeros, 1, 2, 3, and 6. 1, 2, 3, 4, 5, 6. Okay, so they look something like this. And I need my graph to look like this. So that means I'm going to start here. And since they all have multiplicity of 1, there's no bouncing. And so it will look something like that. Okay? In the next one, once again, we have 3 zeros, but they have multiplicity. So I have a 0 at 5, at -2, and at 1. And the degrees are, this is 5, this is 1, and this is 2. So what is that? 5, 6, 8. I have a degree of 8. And my leading coefficient is negative. So what am I going to do with that? Okay, well, because I have a degree, an even degree, but my leading coefficient is negative, that means my end behavior will look like this. And I'm going to bounce at 1 and have an inflection point at 5. What's an inflection point? You'll see where the graph sort of slows down. So let's graph that. So I have 5, 1, 2, 3, 4, 5. I have -2, and I have +1. So I know this one's going to kind of bounce. So this one's going to kind of bounce through the x-axis. This one's multiplicity of 5 will go through the x-axis, but it's going to slow down. So what will my graph look like? Well, I know I have to start from here. And at -2, I have multiplicity of 1, so it's just going to go through like normal. At, oh, wait a minute. Yeah, at -2. At 1, I have multiplicity of 2. I have an even multiplicity. So that means it's going to come up, and then it's just going to bounce back up. And then when I go through this 5, it has odd multiplicity, but because it's at 5, it's going to kind of have like a little inflection point. It's going to sit there for a minute before it goes through. So it kind of just sits there for just a second, and then it goes through. And that's what that's going to look like. Would you like to pause the video and do the last one? Okay, welcome back. So for this one, I have zeros at 0 and -5. And the one at 0 has a multiplicity of 2, and the one at -5 has a multiplicity of 3, which makes it a 5th degree. And my leading coefficient is positive. So since this is 5th degree, leading coefficient of positive, my end behavior looks like this. Okay, so let's graph it. I'm going to go through 0 and bounce. Oh, I'm going to start at -5. 1, 2, 3, 4, 5. And I'm going to go through -5, but remember, I'm just going to kind of slow down a little bit and then go back up. And then I'm going to go through 0 and bounce. And go back up, and now it looks like a cubic function. All right, let's work backwards. If I give you the graph, let's try to write an equation. Okay? So the first thing we need to try to determine is what is the degree of this. So we know that we have a 0 at 1, 2, 3. We have a 0 at -3. And it looks like it has multiplicity of 1. We have a 0 at -1. But notice how that 0 has sort of that little inflection point I talked about. See how it just kind of slowed down right here? See how it just slowed down? So that tells me it has odd multiplicity. So we're going to say it's 3. Could be 5, but we'll just say it's 3. And then this one will have even multiplicity because it's bounced. So we're going to say it has, at 2, it has multiplicity of 2 because it bounced. My leading coefficient is going to be positive because my degree, I could tell this is an even degree. And let's check what we have. So we add up all the degree, we add all the multiplicities to get our degree, and we get a degree of 6. So that sort of jives with what we have here. So what is this going to look like? We're going to have x minus 3. X plus 1 cubed, x minus 2 squared. Excuse me. All right, in the next one, we have a 0 at -5, and we have a 0 at 4. Notice the 0 at -5. Again, it slows down a little bit, so that tells me there's some multiplicity there, and it's odd multiplicity. So we're going to say that's 3. And then at 4, it bounced, so that means it has even multiplicity. We're going to say that's 2. So then my degree is 5, and it's odd. Notice that it starts and then goes down, so that makes my leading coefficient negative. So how do I write this? Negative x plus 5 cubed, x minus 4 squared. All right, pause the video and see if you can do the last two. Okay. All righty, welcome back. Sorry about that. My video got a little sleepy there. So we have a 0 at -4. So it'll be x plus 4. It looks like it's got odd multiplicity, so we're going to make that 3. And then it has another 0 at 4. And it looks like it has even multiplicity. And so my degree here is 5. My leading coefficient is positive. Okay, on the next one, sorry, I have a 0 at -4. And it looks like it has even multiplicity. And I have another 0 at 4. And it too looks like it has even multiplicity. Okay, I gotta go. So my leading coefficient is negative, and my degree is 4th. Okay? All right, boys and girls, I will see you tomorrow.